Okay, so you might be remembering that while I started the classes on searching, then I spoke one thing that any problem of computer science is nothing. It is merely either searching or sorting, or it is a combination of both, right? So sorting is very important from that perspective. You should understand uh, in which kind of problem you have to sort, and it's not just sort. I mean, just the sort part of sorting is not important. Many other things are also important. That let me just try to give you an example. So let me just tell you that hey, I have given you an array that contains n elements, okay, and then I speak one statement, and that statement is that hey, sort this array, sort this array. So what would you do after this? Would you ask me a counter question, or would you start solving this question? Time complexity is not a big thing until unless you are giving me the right output. Yes. So you should ask me a question that in what order you want me to sort. Whether you want me to sort in ascending order, whether you want me to sort it in descending order, because based on that the logic that you will write in your lines of code, that would differ, right? So whenever somebody asks you to sort something, your first question should be on what basis? On what basis you want me to sort it? Okay, so here I heard two things from you. You said that hey, you want me to sort it in ascending order or descending order. But if let's say I am giving you an array that contains 5, minus 3, 4, 0, minus 1, minus 11, okay, then can these two be the only two bases? I mean, can there be a different basis on which some person can ask you to sort the array? It can be, right? So generally whenever, correct, yeah, magnitude, or I'm not sure what external space means, but yeah, definitely magnitude. So there can be different bases on which you might be asked to sort the array. Generally the misconception that we have in our brain is that hey, if you have to sort something, either it should be in increasing order or decreasing order. No, that doesn't make sense. Somebody can ask you to sort them based on their magnitude. So if somebody asks you to do that, then the lowest magnitude is of 0, then minus 1, then minus 3, then 4, then 5, then 9, and then minus 11. Is it clear to everyone? Did everyone understand it? Yes. So frequency can also be a way in which somebody might ask me to sort the array. So somebody might say that hey, let's say I had minus 3 also over here. So somebody says that hey, if there are elements in your array, then you sort them based on their frequency. It means that the element that has got lowest frequency should come first, and then the element that has got the highest frequency should come last. Okay, so this is sorting based on frequency when I want highest frequency at the last and lowest frequency at beginning. Okay, now at times you can have multiple choices, isn't it? So let's say if you take a look over here, minus 3 is the element whose frequency is 2, which is the highest, and everything else has equal frequency. Okay, so let's say I have to think about 1, 2, 3, 4, 5, 6, 1, 2, 3, first 6 elements, because I know that the last element has to be minus 3, because minus 3 is the only element whose frequency is 2 and everything else has a frequency of 1. So I'm not quite sure what can come here. I'm not quite sure what can come here. In fact, I am okay with any permutation of these things coming in over here. If any permutation of these things come in over here, then I'm okay with that. So there can be situations like this. So guys, others, are you getting this point? Yes, no? I'm just sorting based on frequency, and then I see that there are many elements with frequency 1. So I don't know which should come first, which should come second. I'm okay with any of these. So at times this kind of thing can happen when there are multiple possibilities. There are multiple sequences that represent the sorted version of same old sequence. Okay, cool. So I just wanted to give this as a beginning thing which should be in your mind. Second thing that I want to tell you is that Here you are just sorting integers, and integers are primitive data types, isn't it? Yes, no? Integers are primitive data types. But think of it in this way, will you always be sorting integers? Do you always sort integers? No. Sometimes you might sort so many objects, and each of those objects could be a complex object. Say for example, there is an object called as student, okay, and student has a first name, student has a last name, student has a registration ID, and student has, let's say, rank, okay, and there are multiple instances of this student object. I can have s1, s2, s3, s4, or let's say somebody has created an array of this struct student and array of size 10. Okay, so forget about this. So array 0, array 1, so on till array 9, everything is going to represent one student, right? And within everything there will be these 4 primitive data types, right? So here, how do you sort these things? Here you have to be explicitly specified that on what basis sorting has to be performed, right? So yeah, I'll come to that what you have written, but whoever is asking you to sort these would ask you that, hey, sort the students array based on rank. So when you sort based on rank, you will get something else. When you sort based on, let's say, lexicographic first name, in that case you will get something else. If you sort based on registration ID, then something else. Okay, so yeah, that is the main point that I'm trying to make. So whenever you are trying to sort these objects, then objects cannot be directly compared with each other, but whatever primitive data type that object contains within it can be compared with the other object. So sorting has to be done based on that. So the point is that when you are sorting, comparison is the most important thing. And when I talk about comparison, comparison means something like this, okay, or this, or this, or this, whatsoever. So these kind of things can be performed only with the primitive data types. So whatever operands you have here, they have to be primitive. So if you are sorting objects, objects are not primitives, right? So there you have to specify that you have to sort based on something which is primitive within them, right? So these were few basic things that we have to be very careful about sorting. Now let's go on from here. Okay, so we have heard a lot about sorting. Now for our convenience, we'll pick an integer array to start with. So let's say there is an integer array containing n integers, and I ask you to define the meaning of sorting for me. What does it mean by sorting an integer array in ascending order? Let's fix the order also. So what actually means by it is that I want you to give me an output of it. By output I mean I want you to give me a permutation of it, okay, and that permutation can look something like this, such that that particular permutation obeys this property. So if there is a permutation of this that obeys this particular property, then I can say that, hey, this is a sorted permutation of this. So the question can be as simple as this, that somebody has given you an array of n integers and he wants you to sort that array in ascending order. Okay, so tell me, what can be the most basic approach of doing it, considering the fact that I have told you that whatever is the sorted sequence, that is nothing but a permutation of original sequence. Okay, you can always compare two integers and get your job done. That is a comparison based logic. If let's say forget about comparison for a while, okay, then maybe what you can do is you can generate all the permutations, right? Yes, no? Yeah. So that can be the easiest way. So if let's say the algorithms about sorting which you know, which are let's say selection sort or insertion sort or bubble sort or merge sort, if those algorithms did not exist, okay, still you could have solved this concept through backtracking, because by backtracking you can generate all the permutations of a given sequence, and for a particular permutation you just want to check whether that is a sorted permutation or not. If it is a sorted permutation, then that would be your answer. But it would have a very high time complexity, isn't it? The time complexity would be n factorial, whose order is n raised to power n, and that can be drastically very high, right? So definitely I would not do that, because all of us can use our common sense and do something better than it. Okay, cool. My next question is that for for an array containing n numbers, how many permutations can we think of? There can be n factorial permutations, right? But can you tell me how many permutations out of these n factorial permutations would obey this property? So if the elements are repeated, then I can have multiple permutations which are sorted in nature. So remember those questions which we did where there was an array that contained duplicates, and if you simply consider all the permutations of it, n factorial permutations, then there will be many repetitions. Okay, so that would be the case over here. So if you understand that point, then let us take an example. Let's say there is an array 2, 1, 2, 3. To distinguish this 2 and this 2, I am going to give it a label of 1 and give it a label of 2. And it can have multiple permutations that are sorted. So whatever will be sorted permutation, in that first element is fixed, because smallest element is 1 and it just has one occurrence, right? And last element will be 3. Okay, now the fight would be for the middle two elements. So either I can have first two and then second two, or I can have second two and then first two. Both of them are sorted. Both of them are sorted and both of them are different permutations. Okay, cool. But what is the difference between these two? I mean, there must be some kind of difference, right? Like here I see that this 2 has come here and this 2 has come here, and here I see that this 2 has come here and this 2 has come here. So what is difference between these two? Index. Very good, correct. So index is one way of calling the difference over here. But if let's say I ask you to sort the array, in which basis will you sort it? This is not called as in place. In place basically means that you are not using an additional data structure, an additional array or anything to get your job done. In place is doing something without using extra space. Stability, yes, stability. Okay, so today we are going to learn it, and let me tell you, this is very important thing about sorting. Okay, so let us understand it very clearly. Stability means that if let's say there are multiple instances of the same element, okay, then if in your sorted sequence the first instance comes first and last instance comes last, that is called as stable sorting. So this kind of sorted sequence is stable sorting, and whatever algorithm was responsible for generating this sequence would be called as stable sorting algorithm. But this is called as unstable. Simple, right? See, one thing is clear to understand, that if let's say an array has been given which contains many occurrences of 5. So let's say this was first 5, and then there was second 5, and then there was third 5, and then there was one more 5. Okay. So see, whatever will be the sorted sequence of it, in that sorted sequence, these 5 would come together in a chunk, right? They will definitely come together in a chunk. But there will be only one such permutation where you will have first occurrence coming first, and then second occurrence coming up, and then third occurrence coming up, and then finally fourth occurrence coming up, and then the numbers that are greater than 5, and then before this the numbers that are smaller than 5. So this kind of thing is called as stable sorting. Had it been any other permutation of this, where let's say second instance came first and first instance came last, or third instance came last, something like that, then that would have been an unstable sorted sequence. So this was a very easy example to understand. I hope all of you got it. Now I think some of you might be wondering that why is this important? I mean, we understood what stability is because it was quite easy to understand, but why stability? Why do we need it? I mean, does it really make any difference whether these fives come in this order or they come in some jumbled up order? Does it really make any difference on something that we are going to do? Yes, sorting in the object. Cool. So that makes sense. To save iterations is also a good point that you are saying, and I illustrate that or number of operations. But more important than that is something else, and we'll try to understand that something else. So as I had told you, let's say an array is given to you, and that array contains 2, 1, 2, 1, 3, 3 and 3. Okay, and then let's say one more, it contains 4. Okay, now somebody wants you to sort the elements of this array based on frequency. Okay, sort the elements based on their frequency. So which element will come first? Which element has the lowest frequency in this array? 4 has the lowest frequency, so without doubt 4 will come. And why without doubt? Because there is just one occurrence of 4. Okay, so that one occurrence came over here. Okay, next what should come? Tell me. I can have a 2 also and I can have a 1 also, because if you try to understand, the frequency of 2 is 2 and the frequency of 1 is also 2. So here I can have 1 also and I can have 2 also. But let's say the question tells me that, hey, if there is a tie of frequency, like here, if I call it first occurrence of 2, second occurrence of 2, first occurrence of 1, second occurrence of 1. This also, all of them are having their frequency value equal to 2. So let's say the question asks you that, hey, if there is equality, if you have got multiple contenders for a particular set of positions, then their index positions must be respected. Okay, so what should come first? This 2 should come first, and then this 1 should come, and then this 2 should come, and then this 1 should come. Okay, and then these 3. So this is first occurrence of 3, second occurrence of 3, third occurrence of 3. All of them are having same frequency, which is 3, but I want to preserve their order, so they should be coming in this order. Okay, so if the question explicitly asks you to do it, if the question explicitly says you that in case of tie you have to respect the index positions, then stability is of paramount importance, because if you don't do that, you will end up getting some other sequence and your answer would be different. Because here it was okay, here 1 2 2 3 and 1 2 2 3 are actually the same, but here 4 1 2 1 2 is different from this thing. Okay, what I have here would be different from something else, right? So this is a very important point to understand. So whenever indices are of importance to me, then it becomes important. Okay, second example is that while you are trying to sort some non-primitive data type, so let me take example of a structure which is, let's say, timing. Okay, so let's say timing is denoted by x and y. X is the start time and y is the end time. Let me call them start time and end time. Okay, so let's say there are certain movies, okay, certain movies, and they have their starting and ending time as follows. So for the first movie, it starts at 2 p.m. ends at 1 p.m, then 1 p.m. to 4 p.m, then 2 p.m. to 5 p.m, and then 3 p.m. to, let's say, 9 p.m. Okay, let's say these are the timings of movie. So somebody can ask me that, hey, I want you to sort these timings. Now the first question that you will ask is that, hey, on what basis you want me to sort them? Do you want me to sort them based on their duration? If you want that, then the smallest duration is this, so maybe this should come first. If you want me to sort them based on their end time, then I'll have some different sequence. If you want to sort them based on start time, then there will be different answer. So if you want me to, let's say, sort them based on their start time, the smallest start time is of this, so this should come first, and of course the highest start time is of this, so this should come in the last. Now the question might explicitly say you that, hey, if there are two movies, okay, that are having the same start time, then ensure it that whatever is the first movie stored in this array, okay, that should come first and second should come later. So obviously this 2 3 should come first and this 2 5 should come later. Okay, So in that case, what I am doing, that I am not disturbing the relative position of end time of such movies which are having similar start time, right? So these are the instances where stability will be very important. And let me tell you very clearly that you will not be seeing questions where you have to simply sort an array and things like those. Please expect it right from day one. That in interviews it happens like that, because your interviewer will expect you to be very comfortable at sorting custom objects, and I will tell you the way to do that very easily. Okay, the most important point for you to understand here is that while you are sorting, then you should know that what you are sorting. If that is a non-primitive data type, then on what basis I have to sort. Okay,